And we are in the first lesson of the SAT Math. I want to welcome everyone who decided to join our lesson. First of all, thanks for joining, and I hope that by the end of the program you will learn a lot of things related to SAT and you won't end up like this cat in the corner thinking of these formulas and getting confused. So, without further ado, let's give it a shot. So, as many of you may know or may not know, in SAT we have 4 different domains, 4 different niche, I would call them, that everyone must ace in order to get highest score in SAT. And the first one is algebra, followed by advanced math, geometry, and trig. So we gotta cover all of them step by step, but in this slide, in this video, in this lesson I would call, we'll only cover algebra. So as you can see on the SAT, algebra focuses primarily on linear equations, linear functions, inequalities, and system of equations, making it the foundation for much rest of the math section. So yeah, basically you will learn basic stuff that you are maybe already familiar from your prior school years. And this is gonna be just a recap, revision for people who already covered these kind of simple topics in their school. Now to the next slide, we are here to look at our agenda today, what we're gonna cover. And the first thing is numbers in math, followed by expressions, exponents, and low exponents, and many more. Without further ado, let's start off with the numbers in the SAT, or in math in general. So specifically, as you can see, we have our axis here. And as you can see, numbers to the left side go decrease, negative numbers they call in other words. And numbers to the right side, they are positive numbers and they are increasing, as you can see. This axis looks to the right side, which means it is increasing. So we have different sectors, different categories in SAT that you already may know about it, but let's cover them very quickly. We have natural numbers from 1 to infinity. You may count numbers like as a decimal form or in other form. But in whole numbers, as it says, as the name suggests, whole numbers, we gotta include only the numbers which are whole numbers, if it makes sense. So they have to be whole numbers, and we can't say this number is a whole number because 2 from the root comes with 1.334 or something, if I'm not mistaken, which is not a whole number. This is also not a whole number, and p is also not a whole number. The whole number is 1, 2, 3, 4, 5, and so on. That's called whole numbers. When we have integers mean they can be from the minus infinity to the infinity itself, to the positive infinity. And they must be whole numbers as well. So you can't say that this one is basically integer. So they belong to another category. Now we have rational numbers. A rational number is one that can be expressed as a ratio, a over b, where a and b are integers. So as you can see, rational number has to be in ratio form, in fraction, in other words. So for instance, but it also says that integers and b is not 0. So b cannot be 0, obviously, such as this one and that one. So basically this one is decimal, and we can consider as a rational number as well. And this is also a rational number because based on the rule, denominator is not equal to 0, which means that's fine. And we see the pattern. We see the pattern that a over b and 2 over 3. That's the rational number. That makes sense. Cool. And the last one is irrational numbers. Irrational numbers, any number, real number that is not rational, is irrational. Sorry. That means that we have, apart from ordinary numbers that you may see in your regular life, we have also irrational numbers. Irrational numbers mainly include roots and pi, and we also have imaginary numbers, which usually you rarely come across in SAT nowadays, but they are included as a separate topic. But they're easy. I'll tell you, they're easy because we learn only basic stuff here for the SAT. That's about it. That's all what we have to know about the numbers in SAT. Moving on. Where is the slide? It's now we are entering in the chapter of expressions and variables. This is also basic stuff which may be familiar to most of you, if not all, but as a part of this topic, we're gonna just quickly go through this and complete it. So the first thing is we have to know addition, subtraction, multiplication, and division. Obviously, as the name suggests, for addition you add, subtraction or minus, it says use subtract, minus, multiplication or the product of is just multiplying. Division, or in other words, you will see quotient, is you will just divide it as a fraction. That's about it. Nothing fancy, nothing complex and difficult. You just gotta know this. And we have writing equations. You will be given word text, let's say, and you gotta write down the numbers from that word text. That's very simple. You won't actually encounter an SAT, but you gotta know in order to solve other complex tasks. For instance, let's look at this. 14 plus and equals to 7. That means that 14 and a number equals to 7. So whenever you see and, you gotta just add them up, because you are getting one thing, and by saying and, you are getting another thing and adding these two things. That's why you add them up. There's just shortcuts. I'm gonna go through shortcuts. And stands for plus. Then it says a number. So it's up to you. Since you don't know what number it is, you will get either X and A, B, C, which letter you prefer, you gotta put there, but that must be unknown. Equals to 7. That's simple. Equals means equals to 7. So we wrote what we read. This is very simple. There are some a little bit confusing maybe cases. Let's say like this one. This is an equation and it says 7 is a number 2 times less than 8. As you may read here, I have one great hint to solve this equation. Whenever you see then, the word then, first write the equation, after then continue before then, if it makes sense. For example, in this case, it says 7 here is, so as there is another shortcut, is means all the time equals to something. It means something equals to another thing. So just remember for yourself. Is a number. So since we don't know which number it is, we gotta get just X, or you may prefer to get N or A, whatever you prefer to do, 2 times less than 8. See? So if we were to go with this part, if we go with just by reading it, it would be a little bit different to set up this equation. But by implementing this advice, hint, we have to first write everything after it, or after this. We have only 8 after this, so we first write 8, then every equation that is set before it. That's how we solve this, if it makes sense. I mean, like, it is systematic stuff, so if with the help of enough practice, hopefully you'll be able to ace this. It may be a little bit confusing for the first time, but anyways, if it's not, then you're fine, you're doing well. We have a different callings or words to call certain numbers. So for example, you may also know this. This is the base, this is a coefficient and base, whole number, I mean like everything included here. And this 2 called power. Any number in power, in small number above it, called power. For example, 5 to the power of 2 or 7 to the power of 3. So we also have a variable. A variable is the number which is unknown. We call it variable. This may be Y, this may be A, this is maybe N, and whichever letter you prefer to put here. And obviously, the number is called number. That's it. You may read it as 5x to the power of 2. This is how we read it. Also, what you have to know is, this may be a little bit confusing, but you gotta know this. No more means, so let me get, sorry, I need a pen. Here it is to illustrate it. So there are signs in SAT or in math in general. There are some words that suggest you the same thing, but from the words you gotta understand which sign they are. So in other words, it says no more. It would be like, let's say our X number, well, that's 2 bold in it. Let's change the settings. Let's play around. So how can I change it? Let's get this pen and just sorry for that. Where's the eraser? I need the eraser. Technical issues. Oops. Cool. Now let's say we have X number and that number is no more. Oops. This number is no more than Y number. See? But we don't need this part, by the way. It's just no more than this number. That's it. Which means that our X number cannot be more than this one. So this sign means that Y is more than X. And another case with this one, no less means, let's go with X here, and X no less than Y, which means that X cannot be less than Y. So X is bigger than Y. From the meaning, we gotta know about it. And it says at most, which means that it's either equals or bigger than that. For example, the same case with X. Let's say this one is X and this one is at most it's same. So it can't go beyond this. At most it may be equal to Y number, but in either way it can't go beyond this number because it says at most. That's about it. From the name it suggests. So X is at most the Y number basically, which means that Y is bigger than X, or in some cases they may be equal. At least means the vice versa. X cannot be, so X means at least equal to this one, or it is bigger than this Y. That's about it. This is the concept. It may be, of course, confusing with you with this X and Y, but I'm sure that with enough practice, you will be able to ace them. It's not that difficult thing compared to other topics that we're gonna cover in the future. And now let's try to solve this example. Mr. and Mrs. Sawyer, sorry for misspelling this name, are taking their 3 children to an amusement park. The admission is $8 per adult and $C per child. This is important. This information is important. And it is advised to highlight those keywords, but obviously in SAT you won't be able to highlight them in math section, but in English section, yes, you're fine. But it's just a good habit to implement. So A for adults, C for child, and the cost of each ride is $8. That's it. We've got all information here. And it says the question asks, write an expression for the cost of admission plus 10 rides for the family. If we were to set up an equation, we would write it like Mr. and Mrs. So there are 2 people, one and this one. And they are adults because they are taking their children. So, which means that we have 2 adults, 2A, plus how many children? 3 children. 3S, sorry, C. And it also says, and the cost of each ride is $10. So we don't know how many rides there, but we know that the one cost of the ride costs $10. This is how we set up an equation. For the second one, it says find the cost of admission plus 10 rides if the admission per adult is $20 and the admission, just a moment, and admission per child is $12 and the cost of each ride is $8. Now, let's try to set up this equation. We know that 3S, there are 3 children, and it says it costs how much for the children? Okay, let's start off with parent, with adults, because it goes by order. Per adult is 20. That means that if there were two adults, we'll multiply by 20 per adult, then add them up to the cost of children, which costs $15. Oops, $12. My bad. It costs what? The admission per child is $12, which means we had to multiply it by 12. and the cost of each write is $8. So since we know that there are 10 writes in total, and each of them costs $8, we just multiply. This is how we set up an equation for the second one. That's about it. Moving on. Now we have exponents and order of operations in SAT. So basically this is also it is considered one of the simplest tasks, simplest topics to cover in SAT. I mean, like, we are in the entering phase, we are in the kind of introduction topic. So it is okay for you to see a lot of familiar stuff from math. So anyways, to solve these equations, there's a golden rule here above. It says always remove the brackets first. Then multiplication before addition. Terms only can be combined. Keep the signs plus and minus with the terms. I mean, like, let me show it in practice, because there's not a lot to explain. First thing what we have to do here to find out in the brackets, since we have different numbers in the brackets, one is in the power of 2 and one is in the power of 1, and third one is just a number which is not similar, we keep it simple. We don't change anything because it's already in this form. We just have to multiply it. The first thing that comes here is multiplication. We have to multiply it with the method of FOIL for each, and it would be like 2 over a squared minus, pay attention, minus, if there is nothing, that means we have plus, but minus with plus gives minus 2 over 3a. And if we also multiply it, this 3 will cancel and it will be only 2, minus 2. Then the continuation follows the same pattern. If you multiply it with the method of FOIL, 1 by 1 for each, you'll get what? You'll get plus 1 over 3 squared, a squared, plus what? 2a over 3, and plus, if you multiply these two, this remaining, this will cancel, you'll be left with plus 2. Now from here, as you can see, we have similar things. So we can cancel these two with plus and minus because they're similar, they can be cancelled. And we have what? 2 over 3 a squared minus 1 over 3 a squared. So we have to add them up. It will be 3 over 3a squared. That means this will be divided. It will be just a squared. Then we're left with, we have to simplify these two. It means they have to be cancelled with minus and plus. They have to be cancelled. So all what we're left is a squared. If I didn't make any simple mistakes, our answer. This is how we solve other equations. Basically, I could solve all of them, but that's going to take a bit time. So I'll leave it for you. However, I would like to explain this one after explaining this one. Why? Because we have some things to memorize there. Distributive property, in other words, opening the brackets. We have distributive property here. We just multiply it with the method of FOIL here. Nothing is difficult. But with special products, though, we gotta remember, we gotta just memorize probably if we don't know about them as a rule. Whenever we see this equation here, if we want to open this, it will be in this form all the time. It's with variables here, but in real life, in real equations from SAT, you'll be maybe given with numbers and variables. That's not a problem. You'll just gotta remember this formula and implement it. If you know it, that's fine. If you don't know it, you gotta practice and that will be fine. The same case with minus. Pay attention here to the plus. So after you open this, it will be a squared minus 2ab plus. Because why plus? Because you may see that any number, let's say 5, if you square this number, basically we'll just multiply 5 minus 5 and minus 5 twice. That will be 25 because if you multiply 2 minus, they will cancel and it will be plus. The same principle applies here. If you square a number to the power of 2, which means it will be plus automatically. Just remember, that's about it. And this is just also pattern that you also have to be familiar with. And any number in squared minus or plus any number in squared could be written in this form, a plus b or a minus b. Because if you open them, if you multiply with the method of FOIL, you'll get the same result, the same thing. Now, having this in mind, let's slightly jump to the example here. It says, which of the following is equal to the expression shown above? Now, first of all, what we have to do, probably I would suggest to see the formula. Specifically, it looks close to the formula of this one, the second one. I mean, like both of them are similar, but to this one specifically. Where we have minus, that's enough, which means we are dealing with the minus formula. So in the bracket, it must be minus. And as you can see, everywhere we have minus. So it's not a solution, it's not a way of working with it. We have to just open the brackets by knowing this formula for each. So a is wrong because if we square x squared, it will be x fourths to the power of 4, but we have x to the power of 2. You know what I like to do in SAT? I like to start off with the first one, with A, then go with the reversed order, with the D, then again with B, then C. This is my way of solving it. It is totally up to you. It's individual preference. If you wish, you can go one by one, but in most cases, not in most, but in some or in relatively more cases, you may see that SAT tries to put those long equations for you to try it solve one by one, and at the end you will get the result, the correct answer, which is in D, but it may not be true all the time. But this is my method of solving it, to solve it fastly, right? So let's start off with D then. If we square it, we'll get what? We'll get 4x to the power of 2 minus, based on this formula, 2 multiplied a and b. That means that 4x multiplied by 3, it means 3y, which means 12x. Then it will be plus 9y. Here it is. Here is the exact solution squared. This is our answer. If I were an exam day, I would definitely get this. And for the sake of completion, let's look at this one as well. So if we can't multiply it, we can't square 2, because if we square it, it will be in the power of 4, but we are looking in the power of 2. And the same goes here. At the end, if we square this, it will be y in the power of 4, but we are not looking for it. We are looking for y in the power of 2. So that's about it. Moving on. We have laws of exponents and polynomials. So laws of exponents means basically solving the numbers by multiplying them with their power, with their exponents. Exponents means for all integer m and a and any non-zero number a and b, the following properties hold. So exponents means basically the numbers in the power of any number. Let's say here it is. Here's the case. We see that a in the power of m multiplied by a in the power of n. If we multiply, if our base, pay attention, if our base are similar, then in that case we have to add them. We have to add the power, that is exponents. Here is the examples. So you may take a look here. Our base, which is 2, are similar, and but these exponents are different. So we just add them up and we'll get the answer 2 in the power of 8. And if we see in this pattern, if we see that m in the power of m in the brackets n squared, then as you can see, we gotta just multiply it. We just have to use the method of FOIL and multiply only to the exponents, not to the number. So example, you may see from there. So 2 in the power of third in brackets in the power of 5 could be written as 2 in the power of 15. We just multiply these two, but don't add them. Don't confuse these two. It is, of course, advised to memorize them and practice them. In this way, I hope that you'll get better if you are not good in these type of things. And if we have any two numbers in the brackets and one exponent or power for each, then we can write in this form. Because if you think logically, if you open with the method of FOIL, you'll get the same thing. So they are interchangeable, very cool. There it is. So there's the example. You may write it either this way or that way. This doesn't make difference. There's the answer. Now, if you want to divide the numbers with the same base, in this case, we got same base, AA, but our exponents are different, that's fine. We just have to subtract them, that's it. For multiplication, we have to add them, but for division, we have to subtract them. Here's the example. 2 over 5 divided by 2 over 3, that equals to 2 in the power of 5 minus 3. There's the result. That's about it. I'm gonna go quickly here because it's been a long minute. It's been a long time. Basically, we have been recording this. So the same thing with this one, with division. If two numbers in division are in the same brackets and they have one exponent for each, then we can write it as this one for m for each, because they're interchangeable, as we talked earlier. Here it is. Here's the example. There's this equation, and you can write it either this way, and from there you may calculate, of course, and get this result. Simplify things around. And there are terms actually that you have to know. First one is which means that one term, mono. Example 5x. This is monomial. And binomial or binomial, I think it's not binomial. It means like there are two terms. There's one term and second, another one. So they are binomials. You call it binomial. And trinomial, there are three terms, obviously, because it says three. There's one term, second term, and third term. This is in the power of 2, by the way. This means like in the power of 2. X squared, in other words. Polynomial means any of these above. General name. That's it. This is just general name for all. And as you know, like as we did in previous example, this is the method of FOIL. In other words, FOIL stands for first, outer, inner, last method. In simple terms, it would be multiplying 1 by 1. So you gotta multiply this x, starting off with this x, by this one. Then after that, you will multiply by this one. You do the same thing with this one. You multiply 1 by 1. X means first, and what is? I mean, like, this is outside, this is the last term. Yeah, I mean, like, this is the interpretation of it. If you open the brackets in this way, you'll get the result, which is in the quadratic form, discriminant, which is the different topic that we're going to cover soon. Here are some examples that you might want to do. Okay, let me show some of them. Basically, if you want to open them up, we'll multiply them, 10x, that will be 4x, sorry, just a 4 plus, sorry, minus, this is minus, because we're multiplying these two, minus 25x squared, then minus 10x. So if we try to simplify things around, this will cancel out. We'll be left with this equation, which is option B. And try to pay attention to every single detail, because SAT, unlike other testing systems, SAT knows where you're gonna make mistake. And those test takers, sorry, those test makers, they deliberately try to give other scenarios, other alternatives and possible solutions for the one equation. For example, I may calculate it as a plus, then it will be a different scenario. So they come up with the similar convincing option, but if you missed one detail, one single fragment, then even that convincing option is wrong. So they basically, all what they do is just try every method where students can possibly make mistake. That's why be extra cautious about it. Even though the equation may look simple, they may be, you may make simple mistakes as well. Here, let's look at this one. What you have to do, just if you see the same base, you just have to add these two. That will be 3. If you add these two, it will be 2a. Then if you add this b minus b to b, it will be just nothing, because these two will be cancelled. And in the base, we have what? 3, 2a plus 1. Now in this case, we have to basically, as we covered earlier, if we divide these numbers, we have to subtract their power if their base are equal. That means that 2a plus 1 minus 2a. We are subtracting this one from this. So this will cancel, and in the power we have only 1, and below we'll have just 3 in the power of 2. Sorry, 3 in the power of 1, because this cancelled. So that at the end we'll be left with this option. I might also solve this one, but that's gonna take a bit of time, so I'll leave it for you. Try to solve this on your own. These are extra examples. that you also have to solve. Just take a snap, take a screenshot, picture, and we are moving on. The last thing that we're gonna cover today is these three sections, three things. First thing is in SAT, you have mass, density, and volume. There are three things, and you'll be given a word problem where you have to find one of them based on the information. But to find one of them, we have a fixed formula. For example, to find a volume, any volume of this, I don't know, item or whatever you call, you have to divide all the time mass over density. It looks like this. D for density, and you may find volume with this formula. And if you divide mass over what? Over volume, you'll find density. See, the pattern there are kind of interchangeable. And in order to find mass, you may wonder then, should I also divide something to something? No. In this case, it's exception that where you have to multiply the density to the volume. These are golden rules you have to familiar with. The same thing with distance and speed and time. If you want to find time, you divide distance over speed, you'll get t for time. This is c, by the way. Sorry, s. So distance over t gives us what? Speed. And to find distance, we just multiply time and speed, and we'll get d, distance. Also, we have to know one thing, perimeter of this, any figure, let's say rectangular in this case, the perimeter of this is basically looks like 1D. This is the 1D shape where you have just sides. Area means the inside of this thing. You have the area of this side. But we're not going into details into the formulas to find out them. It's just the of these things that we're gonna cover in next class, in geometry and other topics. And volume means this one, 3D shape, 3D. So any item, any construction which has a volume, basically you may take an example of your room where we are sitting right now. If it's most of the time it's rectangular shaped, in any case it is a volume since you are being present and everything is in 3D. That's about it. That's all what we have to know. Other options like 4D and 5D are not defined and we don't actually need them in simple math in SAT. You might want to go back to those previous examples and solve them and just type into the Google for extra examples for yourself. That's about it. That's the whole topic that we had to cover in lesson 1. Thanks for watching. Take care. And of course, you've got this.